And this is the last part for the lighting process, and after that we're going to be talking about compositing. But in this course we will cover some sort of technical specifications that we have to take care of when we're doing the rendering, especially when we're doing a multi-pass rendering AOVs for compositing. On top of splitting all the channels, like the reflection specular channels, here in this shot I actually use a light select, so I have the ability to control how each light performs. Basically the light select stores information for each light for you to be able to control the light after the rendering. And some other things, like I'm going to be talking about how to set up the motion blur parameters properly and how to control the noise, and something like the Z-depth configuration stuff. And in this shot, because we don't really have much movement in this shot, so I might as well just render the whole motion blur in 3D. Sometimes in some other shot, if the camera is moving more or the character is moving more, we may need to render out the vector paths to do the motion blur after in the compositing. Here I'm going to take this actual render file that I used in my project to give a demonstration of those parameters, how this parameter works, because I already set everything up, and you can find this file in the project file as well. And the first thing is, of course, the render resolution, because if we have decided that this film is going to be the aspect ratio of this film is going to be either 235 or 240, so we don't necessarily have to render out the extra pixels, just to save some time. And the second thing to take care of is, well, this is more of like a V-Ray specific case, and on the render probably it's got a different name. It's just how the image is sampled. So basically how much the noise is gonna be in the final image. And by default, V-Ray gives you the progressive anti-aliasing image sampler. We can control how much time we want to spend on each frame, but it's hard for us to keep the noise amount consistent over the shot, because this only will tell the renderer to say, render this image for 2 minutes and move on to the next. And sometimes if there's no movement in the image, this will give you a really good result, but if there's more movement in this frame, we will have more noise. That's what we don't want. And if there's going to be a noise, we would want the noise to be consistent. So it's better to switch the image sampler back to a bucket render, and we can use the max subdivides to control the quality of the overall image. Test the purpose, I usually use max subdivides as 2. And right now we are at resolution 1920 by 817. That's a 235 aspect ratio. As you can see, because I only set the max subdivides onto 2, and right now we got a lot noise everywhere. And this is good for a test purpose, just to make sure to check everything because after we tweak the lighting in RT, we need to go back to ADV, which is here, to check if all the shader, all the lighting behaves exactly what we wanted. Sometimes, as I said before, there will be some discrepancies between the RT and ADV when it comes to rendering the bump and normal map. And here I add a diagnostic channel called V-resample rate. Here you can see how this image is sampled, and whenever it's red here, it means it's drastically undersampled. And ideally we want to put everything back to bluish and grayish. That's when the sample is at a sweet spot. So what happens if we boost up the max subdivides onto 6? As you can see, immediately the render time gets a heavy hit and it renders a lot slower. And when we put the max divide onto 2, roughly, based on my experience, for a shot like this, if there's a lot of things in the shadow, and if we get a lot of reflection, a good number for 6 to 8 is for this kind of shot. But if you have some extreme highlight and you want to get rid of the noise in the highlight, maybe you need to boost up the number onto maybe 10. The max subdivides number onto 2 to 12. And this because it uses CPU render. Is use CPU render based on how many cores you have in your CPU. The render time will be affected accordingly. For me, I try to keep every frame, the render time for every frame, around 5 minutes ish. So at least for a shot like 300 frames, I can have some result overnight. Here, the next thing I want to talk about is how to set up the motion blur properly. Normally at work, we use the motion blur duration, which means how many frames is half a frame. Normally, we set up the motion blur duration to half a frame, which is 0.5, and set the interval center to 0. What does this mean is when the renderer calculates the motion blur, let's say right now we are at a frame 132. So where the motion blur comes from is that it will take whatever motion we have. Actually, let me just give you a better example. So let's say right now we are at a frame 102, and this is exactly where this geo is at a frame 102. And where does this little blurry pixel come from is that V-Ray will take the geo position at 101.75, which is a quarter frame before the current frame, and will also take a quarter frame after the current frame. So V-Ray will say, okay, at frame 102 it's here, but a quarter before it's there, a quarter after it's there. So this is the range of motion, and anything within this range, we're gonna blur it. So this is where this number comes from. So we use half a frame as motion blur duration, and we use the interval center as 0, which means at the current frame is the interval center. But also here depends on if you actually need to match to a plate, you may need to increase the duration, which means you may need to increase the motion blur amount if the plate is shot under a lower shutter speed. And the GI is pretty much just keep it a default if you are around a V-Ray 3.4 and up. I didn't really have to worry about much about the GI configuration. Well, here it comes to the final very important configuration, which is the render elements, aka multi-pass rendering. So normally when we are doing a full shot rendering, we don't just render out the beauty pass. We actually gonna render out different layers like diffuse layer, specular layer, lighting layer, reflection layer. So we can, in compositing, we can reconstruct this whole shot using those multi-layers. Well, the benefit for doing that is because if we only have a beauty layer, we don't have control over each. Let's say if you want to tweak the highlight after rendering, we don't really have the ability to just isolate the highlight after. So by using this multi-layer system, we can actually tweak the overall image deep into sort of a shader level. And in this shot, I even used a light select. So meaning I did a diffuse and a specular layer separation for each light, because I think I'm at V-Ray 3.4 and it doesn't really have the reflection channel separation function in 3.4, but I think up to 3.6 you can do a diffuse, specular, and a reflection channel for each light. So here is a final image. Now let's just go through each layer to see what information contains in each layer. So as you can see, this is RGB color. We call it beauty pass, and of course we have alpha channel, we have Z depth channel, very important. And this Z depth is a unnormalized Z depth, meaning it's not really an accurate representation of what's the furthest in this shot. It contains all the information we need in this shot in terms of the depth. And I do this because later on we can renormalize this whole Z depth in compositing as well. And we got a GI layer, we got a lighting layer. This lighting layer contains all the lights information, and this is the reflection layer, and we got the refraction layer, because in the final shot I have part of the right beam outside the glass, so I will need a as you can see, there's a little reflection there. I will need the information what's outside the glass. So later on in the compositing, I can color correct or do the ring effect on top of the reflection layer, which is the information that behind the windshield glass. So that's the refraction layer. And next layer is the specular layer. Again, this is all the light specular information. And then now we go into the light information for each light. As you can see, this is one of the screen light diffuse information. So it isolates the diffuse light information for that light. As you can see, as I go through, this is the different layer for each light diffuse channel, and as well as every light has their own specular channel. So in theory, if we did this correctly, we put all these channels together, we can recreate the overall lighting channel information. Same thing, aside from the diffuse layer, we have the specular information for every light. So if we put together the separate specular layer for each light, we should be able to reconstruct. We should be able to recreate the overall specular look. And also, I did a self-illumination channel for the screen. And this is more in the shader level, so you have to set the shader into self-illumination, so you will be able to extract that layer. But later on in compositing, I actually changed the screen content into a new sort of user interface using Nuke 3D system, which I will talk about later. And this is a two more like diagnostic channel. Same the sample rate, we can see how the noise is being controlled, and again, ideally we want to put everything into blue or green. Right now you can see the character and the interior, some part is in red because they are either in shadow or undersampled. One way to fix this, of course, is to lift up this max subdivide number, but depends on the actual shot. If we don't really see the noise, or the noise doesn't really bother much, we can just ignore it. And this is another render ID where it allows us to isolate every part separately. This is pretty much the overall render elements setup. And it takes a little bit of time to set up once while doing the rendering, but this will give you so much more extra benefits in compositing, and you don't really have to, sometimes if it's a small tweak, you don't really have to go back the lighting to re-render the image. If you want to turn off the light, you can do so as well. And the one thing here is that in this shot, I didn't render out the glass texture. I just render out the glass reflection for the interior, and later on we're gonna be adding the glass texture and the glass rain, all the other fun stuff, and all the fun stuff in compositing. So this is pretty much for the lighting and rendering for this shot, and then next chapter we're gonna dive right into the compositing. I'll see you there.
Purchase genuine tutorial. Enjoy the question answering from course tutor in the long term. Join the exclusive Facebook group and learn from each other. Also, you can sign up with Yihu.com. Search for the course ID. Obtain the full learning courseware, project files. Follow us on Facebook. Get closer to become a master in CG field.